Hello, viewers. In this class, we are going to look at logarithmic equation. Here, specifically, we are going to look at how we can, apply change of base, to resolve a logarithmic equation. The question before us is they say solve for x log 3 base s plus log x to base 3 is equals to 2.5. It would have been easier for us to apply the laws of logarithm, having known that this is addition sign, but the base are different. If the base had been made the same, then it would have been possible. But what we need to do in a question like this is that we ensure that one of the base, we need to do some transformation here, so that this log 3x, log 3 to base x must be made as log x to base 3. And how do we do that? From change of base, we said that under normal circumstances, this will become, if we have log x to base y, here we can change to another base. Let's say if log, this is the new base c, x all over log y base c. Okay, for instance, and if we are changing it, if we replace x with c, what will happen is that this will become log x all over log y x, and this become log xs is 1 over what? Log what? Y x. Okay, so similarly we apply the same thing here, because we want to change this one to base 3. This of transformation here will become 1 over log x base 3 plus log x base 3 is equals to 2.5. Simply means 5 over 2. So that's what we've just done here now. Okay, this is change of base. We have shown that in our previous class. Here, what do we need to do here? Here we cannot apply the multiplication rule here, since this is addition, because if we do that, we say this times this, everything will become 1. So here what we need to do, we say let, the next thing we do, we say let this log, let log x base 3 is equals to, assume let's say is a. Okay, so where in this equation now this become 1 over a plus a is equals to 5 over 2. Right, this is a fraction already. With LCM of this fraction is 2a, the LCM is 2a, so we're going to multiply through by the LCM, which is 2a. So here we have a 2a times 1 over a plus 2a times a we have here, then we have a 2a times 5 over 2. Okay, now a we go with a here, they will cancel out. This become 2 times 1 becomes 2, plus 2a times a, that will give us 2a square is equals to, here 2 go with 2, and here we have a 5a. Okay, this is 5a. Now, as we can see, this is already a quadratic equation, but we must collect group all the terms on one side, and this become 2a square minus, this is plus 5, as it crosses this sign of equality, become minus 5a plus 2 is equals to 0. Okay, now this is a quadratic equation. So let's see whether if we can factorize it. If it is factorizable, let's do the test for linear factors. Let's see if b square minus 4ac will give us a perfect square. Our b is minus 5 squared, that will give us 25. minus 4. A is 2 times C, which is 2. So this is 25 minus 16, and that will give us 9. So this equation is factorizable. So we use a factorization method. And you know, in factorization method, what we need to do here, we use this term here to multiply this term. So we have a 2a squared times 2, that will give us 4a squared. 4a squared. Then let's now find all the factors of 4a squared. All the factors, one will become minus a times 4a. If we multiply this, minus a times 4a will give us minus 4a squared. Yeah, this will not go. Then let's try another one. A times minus 4a. This one will give us 4a squared. 4a squared. Now, what we are trying to do is that in factorization, what we need to do, this multiplied by this, the constant term multiplied by the term containing the highest power here. Then we now look for all the factors of this term, so that by the time we find all the factors, if we add it, if we add all the factors of 4a squared, that can be added to give us minus 5a. If we also multiply it, we give us 4a squared. That will be our possible replacement here. So here, minus a minus 4a, that will give us minus 5a, minus a times minus 4a, that will give us 4a squared. So the best replacement here is minus a minus 4a. And if we do that, this becomes 2a squared minus 4a minus a plus 2 is equals to 0. Alright, so we group them in twos. Then the shorty factor here is 2a. We factor it out, 2a, open bracket, a minus 2. Then the shorty factor here is minus 1. So we factor it out. Here we have a minus 2. Here becomes 2a minus 1 in one bracket. Then the other bracket become a minus 2 is equals to 0. Okay, so here either 2a minus 1 is equals to 0 or a minus 2 is equals to 0. So that here a is equals to 2 or 1 over 2. Okay, so our question did not end there, because we said the other time, if we recall, we said that let log x to base 3 is equals to a. But from the definition of logarithm here, we cannot say here that x is equals to 3 raised to power a. From the definition of logarithm, we say that the logarithm of any number is the power to which the base must be raised to give this number. So for us to get x, so we're raising it, we say let this one equals, so that x is equals to 3 raised to power a. Now when a, we look at it, when a is equals to 2, let's find x. So s will become 3 raised to power 2, and that will give us 9. Cool. Let's look at this. When a is equals to half, s will become 3 raised to power half, or simply the square root of what? Of 3. Now, in order for us to see that if our answer is correct, we can put this in this equation. When x is 9, when s is 9, this becomes log 3 is 9. Okay, and if we want to evaluate this logarithm, we say let this logarithm be equal to what? Let's say let it be d. So here from definition, so we can say 3 here is equal to 9 raised to power d. This one is 3 raised to power 1. And here we express this as a common base. This will be 3 raised to power 2d. So that d will become, so 1 is equal to 2d, so that d is equal to half. Is equal to what? Half. Similarly, if we put on this part of the equation, we have a log 3 log 9 base 3, and this is log 3 square. This become 2 from logarithm. This become log 3, and log 3 is 1, which is 2. So from here we have known that this logarithm is half plus 2, which is the same thing as what? 5/2 or 2.5. Okay, so similarly, if we try this with when x is equals to root 3, we are still going to arrive at this answer. So these are the two possible solutions to these questions. Okay, so we know that s is equals to 9 or root 3. Okay, here please, you can look at the questions. There are some of these questions on the board here. You can look at them. We have already resolved this. You can look at this too and also apply the same techniques. Have a nice time. See you in my next virtual class.